So recognizing all sorts of different functional groups, right? So the idea here is ways to synthesize carboxylic acid. So here's a number of functional groups. How could you turn these into carboxylic acids, right? So things to think about: oxidations, right? Carboxylic acid has the carbon of the carboxylic acid has 3 bonds to oxygen. So you need to do oxidations a lot of times to get those things there. So the first one, if it's an aldehyde, right? It's an aldehyde. You're going to want some sort of chromium species, or maybe KMNO4, maybe even, right? Because those are really strongly oxidizing reagents. And that's going to turn that into a carboxylic acid. Okay? And the key is there's multiple ways sometimes to do these. Right? So PCC won't do it. PCC will stop, right? PCC only takes 1 H, but it won't react with an aldehyde. What if you have an ester? Well, we talked about this a little bit. We've gotten there. Esters we can hydrolyze. It means you add water to them. We can do it in both basic and acidic conditions. And we'll be talking about both of those. So one type, so version A, involves maybe strong base, sodium hydroxide, right? Maybe some heat. Another way is acidic conditions in water and some heat, right? We can turn an ester into a carboxylic acid in basic or acidic conditions. You already kind of know how to do this, right? If it's basic conditions, what's the first step going to be? Well, if it's a base, we're looking for an acid, but there's no acid. So the basic conditions, we're going to do the addition, make a tetrahedral intermediate, we're out overall negative charges, kick out the good leaving group, right? We know what we're trying to get to. Acidic conditions, what do we do first? We protonate, then we do addition, then we do tetrahedral intermediate, do a good leaving group, proton transfers, all that kind of stuff to get to carboxylic acid. I'm going to skip the bromine one for a second. OH, again, what do you need to do here? If you have an alcohol, what do you need to do? Again, those strong oxidizing things, chromium, is going to be what you should reach for there. Right? You're going to want to have that chromium. Right? Again, primary alcohol turn out into carboxylic acid. If you have a nitrile, what are you going to need for a nitrile? So that's that. A nitrile, we've done this. You can use acidic or basic conditions to turn that into a carboxylic acid. So again, just like those reagents over here. So these reagents, same exact thing, will work to turn that nitrile into a carboxylic acid. All right? Same exact things will work. So now the one I want to highlight is this one. So I'm going to try to shrink everything else maybe down. Oh. All right. Now there's 2 ways we can deal with this. We can do, one way we already know. One route is nitrile for step 1. And then step 2 could be base or acid, right? As above, right? Strong acid, strong base. This would do an SN2, and this would get us, excuse me, wait a second. Oh, I'll lose a carbon. There we go. This. 1, 2, 1, 2, 3, and there was 3, right? So we can turn a bromine, use cyanide, CN minus, cetro bond N minus, right? Just like up here. Do an SN2, and then we can turn that nitrile into a carboxylic acid using base or acid, right? Above. That's one way to add a 1 carbon piece and turn it into a carboxylic acid. The other way is step 1, this, and then step 2, carbon dioxide. So this is using a Grignard route. And actually then there's step 3, you got to add in H+, actually. So let's explore that. So what's the first step going to be? It's going to be forming that Grignard. And we talked about this mechanism, so hopefully we remember some of this. It's that radical. Okay. So step 1 we've turned carbon 2 from an electrophile into a nucleophile, right? Now it's again negatively charged. and it's going to react with CO, carbon dioxide. Right? So it's a little different, but you can probably see what's going to happen here. It's going to add in. It doesn't matter which oxygen it goes. We break a pi bond, so it could be either one. It's symmetrical. So we've added one carbon here. This is after step 2. 1, 2. Number of carbons, 1, 2, 3. And there's carbon 3. To make this carboxylate. And then, of course, the last step is H+, which is just going to be an acid-base reaction to make carboxylic acid. So here's 2 other ways. One you already really know. A way to add one carbon. And a different way using a Grignard and acetobondo. Now, things you need to think about. Right? Grignards are sensitive to what? When can you not use Grignards? You can't use Grignards if you have OHs, NHs, SHs, or pHs, right? Polar protic solvents, anything with a polar protic, OHs, NHs, anything like that, do not work with Grignards. So if you want to make a carboxylic acid by adding one carbon, should you use a Grignard if you have a polar protic thing around? No, right? If you use strong base, right? So you got to be careful which ones you choose and when you choose them.